Sometimes I don't know when a malapropism is going to happen. I just start going on something, and then it develops. And then I look back on it and go, oh my gosh, that was a malapropism. This time I caught one. I caught one happening. Yes, they just happen. They don't just, I don't plan them out. They're just sort of like, ooh, this is a problem I need to solve. I need to go after this. And then, oh, look, I solved it. Oh, that was a malapropism. Even if I have to do several iterations, sometimes it doesn't occur to me that is a malapropism, which is like the classic signal of a malapropism. Once, twice, three times. Oh, prototyping, done. Finally figured it out. I'm in the middle of one right now, and I just realized that this is a malapropism, and it's a good malapropism. One of the most useful tools I have to help me around the house is an air compressor. A nice big 26-gallon air compressor. It's the biggest one I could find that still had wheels, so I could move it around instead of just put it on the floor and walk away. Pretty much any modern air compressor, in fact, I think every air compressor that's ever existed has a purge valve. So what that means is when you pressurize the compressor, you do your work, whether it's a nail gun or a blaster or filling your tires up. But when you're done, you turn it off, and you're supposed to purge it. You open this valve at the very bottom of the tank, and what it does is it not only decompresses the compressor, the tank, but it blasts out any condensation, water that's inside the tank. That can't be avoided. That's just physics, right? It's taking atmospheric air and compressing it, and what that does is that causes water to precipitate out of the air and into the bottom of the tank. Why do we care? Well, these tanks are steel. They will rust. Every compressor dies. And it's just a matter of how long of a life you want to give it. A good way to kill a compressor is to never open the purge valve and get that water out of there, because it'll rust out the bottom, and then that's it. It'll be dead. And if you're very lucky, it won't do it right in front of your face. Don't worry, these things are only 150 pounds per square inch, so it's not like they're going to blow up or anything like that. Although they'll make a pretty good bang. And probably send a piece of metal going. Not a good situation. So, the purge valve is supposed to be opened when you're done using the compressor, every time. If you're running a shop, usually the instructions are to open the purge valve at the end of the day. But I don't use the compressor all day, and I don't use it every day. But every time I do, I have to open that purge valve. The purge valve is at the very bottom of the tank. It's kind of hard to get to. It's uncomfortable. You got to bend over and get at it, okay? So I also had this thought, because I have the home automation system, how cool would it be to be able to start the compressor, start pressurizing the compressor when I'm not at home, like if I'm on my way home and I know I need to fill the tires up, or blast dust off the dashboard of the car, something that I need the compressor for, because the compressor takes a good few minutes to come up to pressure. So how cool would it be, because I leave the purge valve open when I'm not using it, just to help match the atmosphere. How cool would it be to start the compressor, close that purge valve, and get it going so it's ready and waiting for me when I get home? And then when I'm done, it automatically purges itself. There's the malapropism. Let me explain what I did. All right, so here's the compressor. I take it back. It's a 20-gallon, but it was the biggest I could find. And down here, there's the purge valve. Now I put some extra piping on here so that I could try, an earlier version of the automatic purge, which was with this. This is an actual valve, an automatic valve. Why not go and start with what it's supposed to do? What that does is when it's supplied power, it closes. This is a normally closed valve controller. And when it's supplied power, 120 volts, it closes the valve. And then with springs, when you remove power, it opens the valve. It worked, sort of. And then eventually it just stopped working very well, because apparently it doesn't like a lot of air pressure. So I kept having to lubricate it, and it just became so unreliable that I'd come back. And then, of course, once it's slammed shut, I have to take it apart, use a screwdriver, and open the thing manually. Definitely worse than normal purge valve. See this plate right here? This is how this mated up to it. Okay, so the valve is still in there. I'm going to have to take that out and shorten this run up to do what I have in mind. Lucky you, I'm still putting this together while I'm shooting this video. I have no idea how long this is going to take. I've already bought a few components, and I will show you what my thinking is. So the thought I had after that valve failed, keep the valve that I came with it and just put like a lever on it, and then use a linear actuator. It's a fancy word for something that you apply power to, it extends, or it comes back, right? And what if I used a lever and a linear actuator to open and close the valve this way? It only needs to move 90 degrees. So that's what I did. There's a linear actuator right there. Okay? I supply power to this, DC 12 volts, and it'll extend out. And I reverse the polarity, and it'll come back in. There is the rub. Wait, stop, stop, stop. Hi. Been a while. In fact, it's been 2 years since I started this one. I had a couple things that held me up. Pandemic. In fact, the pandemic is still going on. We're at the end of 2021 right now. So when I started this, there was no pandemic. It wasn't even a glint in the eye. But anyway, I digress. Yeah, I have to stop this one out because the linear actuator idea, I abandoned that. I actually took a completely different direction. I actually found a valve that works. It's a diaphragm valve. And it means I have to put it in the correct way, otherwise, so that the air pressure can hold itself shut. It's funny how it works. It's really neat. It works exactly the way I want it to, just like the previous valve, just like I wanted the previous valve to, the sweeping one, the ball valve. Except this one's fast. It releases and off it goes. So I went ahead and shot the, assembly of the linear actuator and all that good stuff. So if you want to keep watching it, it's going to be after this little interlude. Because I don't want it to go to waste, but I didn't want to waste your time and say, hey, look at all this stuff I did with linear actuator. Oh yeah, I went somewhere else. But before we get to that part, I want to show you how this thing works as it's done now. It works beautifully. There's our compressor. Let's give it a shot. All right, shall we? Hey Siri, start the compressor.
I've sent the request.
And now we'll wait. Okay, so now it's pressurized. Let's see what happens when I turn it off. It should get really loud, even louder than that, and blow everything out of the garage. Hey Siri, turn off the compressor.
You got it.
Just like before. Here's our valve, this brass thing right here. Oh, be quiet. And 110 volts right up to the main leads inside here. So when this is on, this is closed. So let me just go ahead and bleed the rest. So you see I kept the old valve there in case I need to stop that from happening, or I pressurize it in the garage and need to move the whole thing around to the front of the house or something like that. But it begs the question, why don't these compressor manufacturers do this? I mean, yeah, okay, so it's, in my house it's hooked to the home automation system here, but who cares about that? Why can't these things self-seal when you power them and then release that purge when you drop the power? Why can't they do this? Seems like a pretty basic thing to me. I mean, home automation system is just icing on the cake. Self-purging seems kind of basic to me. Anyway, that's enough for this one. 2 years in the making. Okay, good luck everyone. Stay safe. So I happen to have this low voltage point contact module for my home automation system. It's by Smart Home. This has a normally open, a normally closed, and then a common. Okay, what that means is if I put power in the common and then I pull a wire out of the normally closed, the electricity will flow through that way. But this is a single pole double throw. What that means is you got one pole and it can go on or off either way, right? What I need is double throw. Double pole. So I was forced to get a relay. There you go. I've already wired it up a little bit. I did some testing with it last night. This little blue guy here is the actual relay. Okay. So what I've done here is, this is a very intimidating looking thing. I mean, it's on a circuit board and everything. That's one of the reasons why I like it. It's on a circuit board because I can mount it. See these little holes? If it's a raw relay, it's going to be banging around in whatever enclosure that I'm going to make for this thing. I don't want to do that. So there's our double pole, double throws inside this little box right here. Okay, there are 8 contacts on it. 2 are what powers the electromagnet in there that pulls the switch. It's an electronically controlled switch. That's what a relay is. They all just have different voltages and power needs. This one requires 5. So I'll power it by this guy. Through the relay, I will run 12 volts from this. This will power the linear actuator. Okay, so I've got 2 completely separate circuits going on here. I've got the circuit that controls the relay with this, on or off, and then I've got the 2 different directions that I need to do for the linear actuator. And that's what this guy's for. These guys are the jumpers that crisscross the thing. So when this guy is not powered by this guy will contract because he's still being supplied by power by this guy, okay? When I turn this guy on, he will extend. So let's put this together. All right, now to test. Okay. And then okay. Yeah. All right.